Good morning, and you're very welcome to another Signpost webinar. Today we'll be discussing green energy boosting technology for sustainable pig production. With ever increasing pressure on farmers to reduce emissions and become more efficient in the management of manure, what potential opportunities are there available to commercial pig farms? And we're delighted to be joined by Dr. Dermot Hughes, Engineering Lead for GlasPort Bio, to discuss some of the options available to farmers. Dermot, good morning to you.
Good morning, Cathal. How are you doing?
How are you keeping today? All well?
All good now, yeah, all good.
Good, good. And you're very welcome to this morning's webinar. We're also joined by Maurice Deasy, who's going to assist us with the questions later on. Good morning, Maurice. How are you keeping?
Very well.
Good. Where are you based today, Maurice?
We are in Athenry, and the
Yeah.
temperatures have increased this week, so that's good.
Grey skies.
Yeah.
And Dermot, before we get into your presentation, maybe you'll tell us a little bit about your work and maybe to start off, where are you based yourself?
Yeah, so Cathal, we're based in Galway, and I suppose we're developing agricultural solutions for sort of abatement of greenhouse gas emissions, primarily. So we've sort of two arms of the business. We've the manure management side, with working on additives for that, and we also have sort of a feed additive arm of the company as well. So working on ruminant abatement technologies as well. So.
A massive area at the moment, I suppose. There's a huge amount of challenges, but opportunities as well. What made you go down that route, I suppose?
Well, look, I suppose the University of Galway, so they would also been interested in sort of, tinkering with anaerobic environments and trying to move the pathways and the flows of energy within those. And I suppose the need was there to investigate this area, and the mechanism of operation was well understood through the microbiology in the university, so it was really spawned from there.
And farmers are crying out for kind of technologies and silver bullets, so it's very welcome. Just to remind everyone today that we're going to be recording today's session, and just please don't forget to submit your questions to Q&A. So Dermot, if you want to get your slides ready there.
Okay.
In the meantime, just like to remind everyone that there's a podcast version of the Signpost Series webinar available to listen to. So when you're on the move, to keep you up to date, or if you're in the milking parlour or running up and down the yard, you can stick it in the ears and plug in and keep up to date on everything we're talking about. And don't forget that it's on all available podcast platforms. So keep in touch with us. Okay, Dermot,
Okay.
if you want to kick off.
Great stuff. Thanks, Carl. Okay, good morning, everyone, and thanks for logging on this morning. As you know, I'm Dr. Dermot Hughes, and I'm engineering lead with GlasPort Bio. And I'm going to speak to you today about our recent SAI-funded project, GEBTech Plus, which is green energy boosting technology for sustainable pig production. So during the next few slides, I'll introduce GlasPort Bio, outline the problem we're addressing, and briefly explain how our technology works. I'll then move on to talk about the project itself in more detail, and I'll present some of the key findings we've obtained over the years. And finally, we'll talk about some sort of policy and directions that we hope to see. So who we are, briefly, I suppose GlasPort Bio are a Galway-based biotech company, and we're developing innovative solutions for the agriculture sector, primarily to tackle greenhouse gas emissions and increase farm sustainability. We have a team of 10 full-time employees who've been working on these solutions for 15 plus years now at this stage. And we have successfully scaled our slurry amendment technology from small lab scale to large commercial scale through recent funded projects. So we have had a cattle manure focused European Innovation Council Accelerator project, which we completed last year. And then the current project, which I'm going to speak about today, which is an SAI-funded pig manure focused project. And these two projects have helped us to achieve a technology readiness level of 7, which is system prototype demonstration in operational environments. So looking now at the problem, I suppose, and the market opportunity for us and solutions like ours. Look, as we know, I suppose agriculture is directly responsible for 37.8% of national greenhouse gas emissions, with manure management itself accounting for 11.8% of this, primarily through, I suppose, methane and nitrous oxide emissions during storage. So this is a significant portion of the overall total, and I suppose it's one that we believe we have an immediate impact on and a solution for. So as we know, there's a significant number of pressures coming on the farming sector to tackle greenhouse gas emissions, be it from land management or enteric and manure sources. And the Irish government has set out a policy of 25% reduction in greenhouse gas emissions by 2030 for the agricultural sector. Now, these are ambitious targets. And last year we saw the launch of the marginal abatement cost curve to assist farmers and the agricultural sector in mitigating these emissions. Our product's called GasAbate. It's a manure additive that significantly reduces greenhouse gas emissions during storage, in addition to some secondary benefits, which I'll outline today. So this slide, I suppose, highlights the ever-increasing European-wide consensus on the drive for carbon reduction or neutrality. And we've seen that both national governments and processors have made significant pronouncements on carbon reductions or even indeed neutrality in the next sort of 10 to 30 years. So returning then to our GasAbate solution. It is a liquid additive that significantly reduces greenhouse gas emissions from stored manure and slurry through a temporary selective inhibition of methanogens. The application itself is through an automated delivery system, which can be easily installed in a new tank or even retrofitted into an existing tank without the need for access below slats or having to enter a tank or anything like that. So it's a fairly straightforward fit out. It's residue-free and non-biocidal. And our target markets at the minute are the swine, dairy, and beef sectors. And we focused, I suppose, from day one on developing a flexible installation approach. So it really has applicability to any tank size or orientation, or any setup that you might encounter on various farms. The solution has application in all geographies where animal manure is stored. And as you can see down here, this represents a fairly large addressable market. And we believe, I suppose, our solution can have an immediate impact on emissions. So moving on then to the mechanism of action and how our additive endorsing technology suppresses these greenhouse gas emissions from stored manures and slurries. It's a liquid additive, and it works through modulation of the oxidative reduction potential, or ORP, in the slurry. It's a highly selective mechanism, and it causes a temporal inhibition of methanogenic microorganisms, so the bugs that really form the greenhouse gases, while it doesn't affect the remaining microbiome within the slurry. So as you can see here from the graph, the treatment period provides an extended period of inhibition of the methane forming bugs, and then during the initial ORP elevation phase, and you also get a further period of inhibition of several weeks or days as the ORP returns to the baseline. So moving on now to the current project, which focused on the use and benefits of GasAbate for the swine industry. The project GEBTech Plus consisted of 3 partners as the technology innovator and provider. We also had the University of Galway on board as the academic partner, and they were instrumental, I suppose, in the development of the additive, and for this project they provided microbiology and anaerobic digestion expertise also. And lastly, our industry partner, which was Ashley Farms, they helped, I suppose, for us to identify the need and provided the facilities and industry know-how for our trials and deployments of the technology. So briefly on Ashley Farms, it's a 3rd generation family farm based in West Waterford. They place a major emphasis on sustainability, animal health and welfare, and production output. And this is demonstrated by the fact that they produce their own breeding stock. They also manufacture and transport their own feed. And a nice benefit for this project was that they also operate an on-farm biogas plant, which generates biogas from the pig slurry produced on site. You can see the on-farm digester there in the bottom right. They employ about 20 people, and they have a dedicated R&D team. So the project GEBTech Plus, which, as we said, was green energy boosting technology for sustainable pig production, had the following objectives. We wanted to demonstrate at commercial scale GlasPort Bio's GasAbate solution to reduce greenhouse gas emissions. we wanted to demonstrate the improved anaerobic digestion feedstock potential. So as gas abate reduces the greenhouse gas emissions, that carbon, which would have otherwise been, I suppose, lost to the atmosphere, is conserved within the slurry, making it a more energy-rich substrate for anaerobic digestion. We also hope to disseminate our findings, which today forms part of, to enhance wide-scale adoption of the technology and approach. And finally, I suppose, to help shape policy and manure management for greenhouse gas mitigation and enhanced digestion. So if we take a look at the, I suppose, the greenhouse gas energy and nutrient flows of the current practice at the top here, versus utilizing, gas abate, you'll see it as, I suppose, a type of a paradigm shift in manure management and utilization. The current practice results in significant greenhouse gas emissions from stored manure. And I suppose in addition to the environmental harm of these emissions represent a loss of carbon and nitrogen from the manure, greatly reducing its usefulness as either a fertilizer or as an anaerobic digestion feedstock. Whereas by applying gas abate to the stored manure, greenhouse gas emissions can be reduced by up to 80%. This mitigation measure greatly improves manure's value as a fertilizer, which can help to offset the cost of additional mineral fertilizer. And as I said, the retention of carbon can also increase renewable energy output when used as an AD feedstock. So getting down to the project then, we had 5 experimental arms in order to achieve our objectives. Firstly, we had medium scale studies at 1 meter cubed. So these were used to optimize our gas abate application rates for pig slurry. And these were carried out in temperature controlled closed and dynamic chambers to sort of represent the temperatures that pig would be housed at and slurry would be kept at. The closed chamber studies allowed us to investigate the effectiveness of gas abate in strict anaerobic environments and sort of quantify the emission reductions per unit of slurry. While the dynamic chamber studies were used to simulate the pig houses, with the representative airflow being applied across the surface of the slurry. This allowed us to demonstrate the impact of gas abate not only on methane emissions, but also on ammonia and other gases. We also looked at the fertilizer and nutrient content of treated slurry versus untreated. So these were carried out, including extensive plot trials to demonstrate the benefits when comparing, as I say, the treated slurry to untreated slurry. We also wanted to look at the effect of gas abate as an energy boosting solution for AD feedstocks. And this was demonstrated through lab and pilot scale studies, but also, as I said, benefiting from the use of the on-farm digester at Ashley Farms. And I suppose a key engineered solution that we needed to come up with was the development of an automated dosing and monitoring solution. This was undertaken in a number of the pig houses at Ashley Farms, where we used the findings of the earlier medium scale studies to inform the design and the overall solution in the larger full scale setup. So some key considerations which informed the experimental work included optimizing the dosing of pig slurry at medium scale in both the closed and dynamic chambers, the development of a prototype gas detection and engineering the product dosing technology at large scale, and working with Ashley Farms to develop the practical farm scale implementation of this solution. I suppose all the while taking into account the everyday workings on the farm and ensuring that the installation in no way impeded on the pig rearing activities. You can see the picture on the left there gives a glimpse of our containerized test facility. So this is a shipping container that we kitted out as a lab, and this was placed down at Ashley Farms. And our medium scale chamber studies and pilot AD trials were run from in here. So this slide just, I suppose, presents a large fattener shed, which we kitted out with the gas abate solution. The house was partitioned, which was great because it enabled us to operate comparative studies of treated and controlled houses. You can see these two houses here, we treated and controlled side by side, so it was a very good like-for-like comparison for us. I'll go into more details of the installation in the next slide, but you can see from the diagram here that Each pen within the house contains a single injection point for additive addition. Now, this is a picture-heavy slide, but I suppose it's just to try and capture what the installation looks like and how we achieve our aim. If we look at the solution and how we apply it to a typical slatted house, it's a pumped process with additive being taken from a storage tank or IBC. Injection points are then placed at predetermined positions in the tank to provide full coverage. In this case, as I say, one injection point per pen provided the recommended number of injection points for the tank area. Multiple dosing lines can be serviced by a single pump through the use of a manifold. And at the injection position, then, the flexible dosing lines are fed through a stainless steel conduit, which fits between the slats and allows us to terminate the injection point in the correct position right at the base of the tank. Another benefit of the steel tubes, I suppose, is it ensures protection of the dosing line when it's in contact with pigs or slurry. And overall, I suppose the application of the additive is controlled automatically. So the pumps are activated at set interval times. So outside of ensuring that adequate supply is maintained in the tank with the IBC, no operator input is required for our solution. Here we have some more pictures of the installations showing the dosing lines being kept out of reach of pigs. As we all know, pigs are fairly curious creatures, so ensuring that the mechanism is secure was a key design consideration. So here we have some further pictures of a Wiener house installation, showing the various equipment elements such as the sort of pump, manifold, control unit, and you can see there the stainless steel tube passing through the plastic slats. Installation is a fairly straightforward process, and in most instances there's no need to move animals during installation. Monitoring of emission reductions in the houses was achieved through the use of a photoacoustic gas analyzer. So this analyzer continuously monitors the air quality in the houses, measuring gases like methane, ammonia, CO2, and nitrous oxide. We had a number of monitoring points present in each house, and this allowed us to get a full data set from right down at slurry level through the use of emission chambers, right up to roof height. And H2S was also monitored separately. Moving on to the results of the various trials then. Throughout all our trials, we consistently demonstrated a greater than 80% reduction in methane emissions, where gas abate treated slurry was compared to untreated slurry. We had a significant reduction in malodorous compounds as well, with a 50% reduction in ammonia and a 78% reduction in nitrous oxide. We also achieved greater than 80% reduction in hydrogen sulfide in our closed and dynamic chamber assessments. And our in-room monitoring of hydrogen sulfide returned a greater than 18% reduction, leading to a fairly noticeable improvement in air conditions within the rooms. This is noted on by employees. So this represents an overall healthier environment for the pigs and the employees. Next up, we investigated if these reductions in methane emissions and conservation of carbon within the slurry would be translated as improved biogas output when the slurry was used as a feedstock for AB. So this was achieved through a number of assessments. Firstly, we applied the standard biochemical methane potential test. Control and gas abate treated slurry from the closed and dynamic chamber assessments was compared, and the reduced emissions from treated slurry resulted in a significant boost in biogas, with a 57% increase in methane potential being recorded. From there, we ran further tests in 100-litre CSTR pilot digesters, where we had 2 digesters running in parallel, one digesting gas abate treated slurry and the other untreated slurry. So this, I suppose, is a more continuous real-world scenario, more realistic test, and it resulted in a 100% increase in cumulative biogas over a 30-day digestion period. So as I mentioned earlier, Having Ashley Farms as a partner of the project provided us with the opportunity to further validate these findings in their on-farm digester. So on site, they operate a 270 cube digester processing pig slurry throughout the year. For the assessment, slurry from a tank treated with GlasPort was used as a feedstock, and this resulted in a similar finding to the pilot scale work, with a 100% increase in biogas output when compared to the previous highest yield achieved with untreated slurry. So to put some numbers on that, the treated slurry produced 22 cubes of biogas per cube of slurry, compared to the previous highest yield of 11 when digesting untreated slurry. So what we've gathered from these various studies is that we can clearly demonstrate that the carbon being retained in the pig slurry through the reduction of the greenhouse gases can greatly improve the biogas yield from pig slurry, making it a far more valuable feedstock than it may be viewed right now. Another benefit which was observed on the farm was that slurry was far easier to handle following the treatment. It was freer flowing and easier to pump is the message we got from the guys on site. This is something we hope to look into in more detail, as it has been remarked upon previously with our cattle installations also. Finally, moving on to the last experimental arm of the project, which was to look at fertilizer or nutrient potential of the slurry treated with GlasPort. For this, two extensive agronomy trials were undertaken, one by GlasPort Bio and the University of Galway, and another independent study carried out by Queen's University in Belfast. Briefly, treated slurry was directly compared to untreated slurry to determine the increase in N replacement value and the increased yield in perennial ryegrass that can be achieved by applying treated slurry, when obviously comparing it to untreated slurry. The cumulative yield of ryegrass was assessed over a 6-month period from May to October, and 2 different soil types were investigated in the study, a high and medium organic matter soil. All slurries tested were normalized for KS and P, and 4 treatments were applied and 4 harvests were carried out over this test period. Slurry was applied at an equivalent of 33 cubes per hectare. So getting on to the results there. The results indicated an 80% increase in N replacement value, and the ryegrass yield studies showed a 21% increase in yield for the high organic matter soil and a 22% increase with the medium organic matter soil. This clearly demonstrates the positive effect on fertilizer value of slurry that has been treated with GlasPort. So some conclusions from the GEBTech Plus project. Our studies have demonstrated that a peroxide-based slurry additive reduced greenhouse gas and ammonia emissions from stored pig slurry. The carbon content of the slurry was maintained by retention of CO2 and methane, which are usually emitted to the atmosphere. We demonstrated a significant increase in biomethane output at pilot scale and a doubling of biogas production at the farm scale digester. The agronomy trials demonstrated that retained nutrient value maximizes the opportunity for nutrient circularity, and reduced ammonia and hydrogen sulfide emissions are positive for animal health and welfare, as well as for on-farm workers. So this is an interesting finding. I suppose it's something that we plan to explore in greater detail to assess if any productivity gains can be made from this healthier environment for the pigs. We have had a number of peer-reviewed publications come out of the recent projects, which provide more detail on the science and the solution development that I haven't had time to go into today. So they're available at the moment. So if we take a look at the economic and environmental impacts of using GlasPort for maybe the entire Irish pig herd, we can see that the greenhouse gas reducing benefits can make a significant impact on total emissions for this industry. Applying GlasPort to the 1.6 million swine herd nationally has the potential to reduce the total of 0.29 million tonnes of CO2 equivalent, right down to 0.06 million tonnes of CO2 equivalent. In terms of cost, GlasPort compares very favorably to other slurry treatment techniques, such as aeration or acidification, at €34 per tonne of CO2 equivalent, compared to 195 for aeration and 212 for acidification. Using Ashley Farms as an example, we also completed an in-depth climate impact forecast. So as I say, this is an in-depth study. It takes a large number of factors into account to determine the overall carbon impact of using gas abate on a typical farm such as Ashley Farms. The forecasting platform takes a lot of things into consideration, everything from storage conditions and duration, temperature, even down to the cost of producing and transporting the additive and pumping the additive, etc. All these factors are taken into consideration. So for a 3,800 pig farm like Ashley Farms, we could achieve a potential mitigation of 3.1 kilotons of CO2 equivalent per year. Now, some broader project outputs and I suppose a general outlook. As we know, agriculture is a major contributor to Ireland's economy, 18 billion in exports in 23, and 165,000 jobs, many of which are in rural communities. However, we must also recognise that a significant proportion of Ireland's emissions, as I say, close to 40%, come from agriculture, and this is something we must make efforts to address. Major work from Teagasc and DAFM has gone into developing the marginal abatement cost curve to identify technologies which we feel, if adopted, will ensure Ireland achieves its binding EU targets for 2030 and beyond. As stated earlier, slurry management represents 11% of all agricultural emissions, and we believe that the widespread adoption of gas abate can make a significant impact in reducing these emissions, potentially providing up to 9% reduction in all agricultural emissions. As I outlined, gas abate is a very cost-effective means of reducing emissions, whilst at the same time enhances the value of the treated slurry. In order for this adoption to happen, we need, of course, the support of Teagasc, the Department of Agriculture, but also the food and milk processors and the wider farm community, which we feel will in turn help to protect rural jobs and the rural economy. So to recap on the timeline of our development, our two most recent projects have enabled us to develop out our solution at full scale, where we've implemented fully automated systems in the cattle and pig sectors. As I mentioned earlier, we completed an EIC accelerator project on cattle slurry, and that installation is continuing to operate successfully for the past 2 years. And then the current GEBTech Plus project at Ashley Farms, where Ashley will continue to use our solution, having had first-hand experience of the benefits that can be gained from applying gas abate to their stored slurry. Next steps for us are to continue to roll out our solution and increase our number of installations, demonstrating clearly to farmers the benefits of the solution in terms of both emission reductions and slurry fertilizer value. We also plan to investigate if productivity gains can be obtained as a result of the healthier environment for housed pigs. We also hope to broaden the scope of our application to other animal manures and organic wastes. And finally, to demonstrate further the bioenergy gains that can be made for AD operators by using gas abate treated slurry as a feedstock. Finally, I'd like to thank our project partners who helped to make this project a success, especially Ashley Farms, who provided really, really good testbed for us for our technology. And I suppose they brought valuable industry experience in ironing out the kinks of installing a system in a working pig farm. And I'd also like to once again acknowledge the support of SEAI, who funded this project under the SEAI National Energy Research, Development and Demonstration Funding Programme 2021. And I'd like to thank you all for your time and attention this morning.
Dermot, thank you very much. That was a super comprehensive overview of the project of gas abate and the additive and what it can do for us. And I suppose from the get-go, I set a challenge to how can we solve those problems, and you've ticked a lot of boxes there. So that's really interesting. And I see there's lots of questions coming through. I'd just like to remind everybody to keep throwing your questions into the Q&A. You have Dermot here will answer them, and Maurice here is going to ask a few questions in a minute. But Dermot, I suppose I'm going to bring it back a little bit to farm level. So you have Ashley Farms down in Waterford. How long is the project going on there? And I suppose how easy was it to install it? And what's the farmer's perspective? What does the farmer think of it?
Look, the project has been running for about 3 years now. We're just coming to the close of it. The installation has been up and running for well over a year and a half now. And look, the feedback is very positive. I suppose the main thing is we've automated it to an extent where the farmer has very little to do other than ensuring that the IBC has additive in it. And that's sort of a key consideration for us. We don't want to be interfering with the day-to-day operation of the farm. Guys are busy enough trying to rear animals, so
Do you
that's
have
been
it to
our
a
approach.
stage where it's easy enough to install a new system, kind of copy and paste on another farm?
Yeah, for sure. So look, we had the IC Accelerator grant before, which saw us install on a dairy farm down in Chinook. So we took a lot of learnings from that. Obviously, there's a few nuances to the pig side of things, but we had a fair understanding of how we should do this, and it's sort of scaled perfectly to the pig sector as well.
And just on I know we're focused on pigs today, but you did mention cattle as well. Um, is is there a difference between pig and cattle, sorry, to what you're trying to achieve? Does the product work in different ways?
The product doesn't. No, the mechanism of operation is the same, Colin. So I suppose there's subtleties in the difference of the two slurry types. So obviously pigs are stored under warmer conditions. So you may need more additive because the temperatures are elevated, so the emissions will be higher. So your treatment frequency will increase for the pig slurry as compared to the cattle slurry. But in terms of the mechanism, we're trying to achieve the same thing by altering the ORP within the slurry to dampen down the mechanogenic activity.
Yeah, and one last one for you, and we'll go to Maurice then. Is there a difference then, say, for example, most of the slurry tanks you're looking at, I assume, are covered, not open tanks, is there?
Well, it can work in both. I mean, we have installations in other geographies where, primarily there's not much storage under the animals and slurry is removed and put into an external tank. And we've demonstrated that we can do that as well, fairly simply. But for the most case in Ireland, it's going to be slatted houses that you're installing in.
Yeah. Maurice, I'll send you any questions coming into you. I see they're flying in there.
Plenty of questions. Yeah. First off, there's a question on the nutrient analysis of the slurry. So does it change any of the P and K content and the pH of it as well?
No, it won't. It won't change the P. We're not. Obviously, P won't be driven off from the slurry, even with emissions or anything. So we won't alter the P content. Nitrogen is the big one. So look, we're dampening down, as I say, the ammonia emissions from that. So you will see a much higher TN value within your slurry following.
And presumably, there's another question about the smell. So the smell, there was noted less smell within the house. Did that work for neighbours? And I suppose there's another question then on spreading as well. How does that work in spreading? Is there a reduction in smell and low emissions? Would slurry spreading less would be kind of a question mark I'd put in there. Would less be a requirement to make sure you don't lose that nitrogen when you're spreading it?
It's a good question. I suppose it's probably something we need to explore more on the spreading side of things, but certainly the feedback from the house is that owners are down. It seems like a fresher, healthier environment. And also then I suppose maybe on the spreading side of things, a lot of feedback we're getting actually from most farmers is that the slurry is a lot easier to handle. It's easier to agitate. It's more readily pumpable. So there is that benefit to it for sure.
Will there be a minimum size for this system in terms of farm sizes? And there's questions here of interest of can we get it on a signpost farm? I presume that's a signpost farmer asking, can they get it?
Absolutely. Look, our hope would be to roll out on a lot of signpost farms. It's a very scalable system. So, you can go from a very small shed to a larger one. Obviously, there's cost efficiencies in doing a bigger shed for sure. But no, it's applicable anywhere.
There's plenty of questions on the cost. What's the capital cost? What's going to be the running cost of something like this?
Okay, so that's not really my area, but I suppose we have worked up some numbers, and for the additive cost for a pig, we estimate it's probably around €2 to €2.50 per pig finished, so it's not a huge cost over the life of the pig. And then installation costs, again, it's a movable feast depending on, the size of the farm you're doing. But you're looking at around, I'd say, €10 per pig place. Is the cost we've based on the Ashley installation, and then another couple of farms as well. We've sort of sketched it up, and it's looking at around that.
There's another question around the biogas potential. So is some of if the slurry was to be moved off farm to an AD plant, do you think you'd have the same biomethane potential, or is there a potential for loss if this is stored for a long time or in the transport?
No, absolutely. So look, as I say, it's a temporal inhibition. So you can predict when this slurry is going to start losing emissions again. So once it's locked in, that carbon is maintained. So whether it's moving to a centralized AD facility or otherwise, no, the gain will remain.
And does there need to be a time delay between dosing and actually being fed into the AD plant, or can it be fed straight away?
Yeah, it can be fed straight away. So we've done a good bit of studies on that, because it was certainly a concern that Ashley raised, actually, which was useful. Could there be any impact on the actual the consortium within the AG digester? And no, the studies we've done indicate not, because I suppose you're feeding at such a rate that the reducing conditions within the digester will actually eliminate any harmful effects of the additive on the bugs within the digester.
And there's a question on the carbon footprint of the additive as well. I presume that's included in your LCAs and when you're looking at the savings.
It is, yeah. It's a fairly extensive LCA, so we had to take everything into account from shipping to transport and etc. etc. So yeah, it's all there.
And is there any evidence that the bacteria in the slurry will become resistant to the additive? And I suppose I might add to that, and does the additive affect the bacterial content in the slurry at all, or have you looked at that?
No, it doesn't. We have looked at it in fair detail. So as I say, it's non-biocidal. So what you're doing is you're adjusting the environment rather than actually knocking out bugs or eliminating bugs, the methane forming bugs from the slurry. So you're just making the environment unfavorable for them, which knocks out the pathway for the methane production.
All actions are temporary, is the do you need to increase the capacity of the tank for the more liquid volume? I assume no, it's an IBC for a pig shed. It's not a measurable increase.
It's a very small volume of additive required for a ton of slurry, say, for instance.
Do you plan on looking at the emissions on separated slurry, separation?
Yeah, it is something we've looked at. I suppose you will be treating the slurry and then separating it after, as opposed to applying it to the separated fractions. Yeah, it's something we've looked at. Obviously, most of your emissions will still come from the solid portion. We've looked at the methane emissions coming from the liquid fraction, and it's very small in the overall context of what's emitted.
But I suppose then it'd come back to the low emission slurry spreading as well, if there's high ammonia and how it's spread as well. Can you speculate how gas abate might work in a combination with slurry aeration systems? Could it work with a slurry aeration system? Are there different mechanisms?
There probably wouldn't be much point in doing that. Because I mean, if you're running it, if you've spent the capital on aeration, it's doing what you want it to do in terms of odors and methane emissions and all that. But they wouldn't really work in concert, because they're kind of doing the same thing, other than we're not driving off a lot of ammonia that's typical with aeration systems. So we're cutting down on the methane, but we're not losing the ammonia.
Dermot, sorry, Maurice, I just slightly changed topic a little bit, but you mentioned H2S, hydrogen sulfide. Why was that a concern for you in the project, or why did you target that?
So look, H2S, as we know, is a nasty and dangerous gas, for farmers or operators on site. So it was, one of the main issues we talk to pig farmers is the neighbors. The neighbors are complaining about odors. So we wanted to see if our additive would have a big impact on that as well. And the feedback so far is fairly positive that, yeah, and look, the numbers are saying as well that we're cutting down on H2S significantly. So there's that angle of it, for the neighbours of the farm, less odors, but there's also the angle we want to look at is the pig health, and can we see any benefits from that nicer environment for them in terms of mortality or productivity or finishing times, etc.
Yeah, and just want to bring you back a little bit of cost, and I know it's a horrible subject to chat, but it's a big one for any farmers listening. You're saying €10 per pig. So do you, because this is obviously really good for abatement, do you see this as a requirement for support? And I'm not just talking about implementation, but also, I suppose, continuous support. Or do you see it that farmers will be mixed, maybe that they can generate some money from maybe selling the digestate?
Yeah, sure. Look, I mean, yeah, at the minute, the digestate is probably the big seller, the big benefit. Certainly if you can get receipt for that, it's great. If we can link the productivity to it, I think it's also a bit of a no-brainer. It really cuts down on the cost of it, which isn't I suppose comparatively isn't high as it is, but if we can get some sort of productivity benefit on it, I think the farmers will certainly see the merit in it.
There's a question here on can the treated slurry be used on organic farms?
That's a good question. That's not one I can answer at the minute now, Maurice.
Yeah,
I
it's a
assume
question for.
if it's not organic feed, I would say for the unit, I assume it wouldn't be allowed to be used. But that's an
Yeah.
assumption. We'd have to get one of our organic specialists in to talk about that.
Yeah, I presume, as in, if it's slurry that is suitable for use in organics, would the additive change the organic dairy designation of that slurry? I suppose that's a question for the
Mm,
regulators and that side of things.
yeah.
Um,
Just wondering, Dermot, during the research, with all research, when you're trying to find solutions, did any other challenges emerge during the research that I'm not saying problems, but something maybe that could be an opportunity as well, some other opportunities that you might come across?
Um, no, the challenges with pigs is pigs chewing everything. So we had to come across designs. So there's a few iterations of how we actually get it into the tanks, but that's sort of a practical challenge. But no, in terms of the installation and how the additive is added, it's been fairly plain sailing, really. As I said, there's a lot of learnings from the cattle slurry, and pig slurry has a lot less solids in it, so issues are probably even less than with pig slurry. So it was very
a
straightforward.
question on seasonality. I suppose in a pig system, there's always slurry being produced. But say for a cattle system, if we're talking about winter slurry, the
Yeah.
volumes will be probably changing. And then I suppose that question is, how long would you have to keep the system running until all of the slurry is spread, basically? Is that kind of the.
Yeah, so with the cattle slurry, obviously that is a challenge, because obviously just when the close season is over, it's not necessarily the tanks are going to be emptied. So our strategy with dosing cattle slurry is that we have for fresh slurry, we have a treatment dose that's applied, and then for slurry that's already received a treatment, there's a maintenance dose, so it's a much reduced volume that the slurry requires just to keep that ORP topped up, that ORP increase topped up. So, when cattle go out and there isn't fresh slurry being added, you will be essentially dribbling in a maintenance dose until the tank is emptied.
Yeah. And I suppose there's a question there as well, will the slurry crust over? As in a good crust will reduce emissions, but does the increased handling reduce the amount of crust forming on the slurry?
Yeah, to date, it looks that way. It looks that we don't get as thick a crust forming, because obviously you're applying a dose every couple of weeks in the case of the cattle, and and the reaction of the additive going into the slurry actually keeps the slurry looser, so you don't get this heavy crust on it, which in one way benefits agitation, in that it will take less time to agitate a tank where gas bit has been applied.
And there's a question here actually on handling the slurry. Will handling the slurry help move the additive around the system, or say in that cattle scenario, should everything be left stationary and just leave that maintenance dose do its work?
Yeah, you probably as well just leave the maintenance dose do its work, because look, if it's moved, we can't be treating it, and if it's left in situ, um, the system is designed to give you full coverage in the tank. So whatever's in there will be effectively treated by the maintenance dose.
From a farmer's point of view, it's going back to you. You've already answered your question, but for additives, the first thing that a farmer look for on the side of that tub is when I stick the agitator in, will I agitate it really quickly? So you've seen that on Ashley Farms, have you?
Yeah, sure. Look, it's obviously something we need to sort of try and quantify in some sense, but yeah, the feedback we're getting is, look, they've never been able to empty their tanks as low as with the additive. It just makes everything a bit freer flowing and cuts down on sort of solids accumulation and that sort of stuff. So
And I know there's grants out there now for tillage farmers to take in slurry, and a lot of tillage farmers would take in pig slurry. And I suppose it's something that we have to be careful that to make sure it goes out at the right time. But so your system, I suppose, if a tillage farmer has tanks, that you could install it there as well.
yeah,
You-
absolutely.
Yeah,
Yeah.
big overground tanker, even if it's something like that.
Yeah. So look, we've done some studies with pig farms in Germany, and as I say, that's the norm there. They have very little storage under the animals, so it's kept in your glass lined tank on site, and we've installed them there
And
successfully.
there's no, is there an issue then with, say, rainwater on top of it then? Do you have to up the dose, or does that affect it at all?
Yeah, you will adjust the dose based on sort of rainwater input. So, we have different levels of installation. So where there is an input of rainwater, etc., you'll put a level probe into the tank, and then the dosing will be adjusted according to the level in the tank.
However, best practice is everything should be covered is the standard answer, lads. No open storage.
It'd
Down to that sort of thing.
make life a lot easier anyway, wouldn't it? Yeah,
Yeah,
Rupa. Yeah.
There's a question here about, can you explain nitrates and exporting slurry to digestate back to farmland? Might tag one of my own Signpost webinars talking about Renure. That probably goes through that whole cycle of nitrates and what is designated organic manure and not, and potential solutions for the future. Very good question here. What does the presenter see as the big obstacle to overcome now in terms of technology development?
I suppose just acceptance from the farmers, and you know a, a real demonstration of the need for our solution. That's coming down the tracks. There's pressure on everybody. Um, it's a ready-made solution, so it's really just it's getting installations out there and letting farmers see what it can do for them, really.
And I suppose the farmer is being valued for that emissions reduction that the farmer isn't paying for this, and then the inventory still says, well, actually, you're at full emissions.
Yeah, so look, ideally we'd like to get on the inventory list. Obviously, so where our installation is there, you get that credit for having it and operating it. But yeah, we have to get there, I guess.
Is AD happening fast enough, Dermot, do you think, for you to I suppose to support what you're trying to achieve here?
Yeah, look, obviously it's the clear benefit at the minute. And there probably isn't enough AD out there, as we know, but um, I think based on the findings at Ashley Farms, I think a lot of people will look at pig slurry in a different way now. It was often seen as, not a great feedstock, but by using Gasovich, we've shown on Ashley we can double the output, which should hopefully make people look at it in a different sense.
I suppose
Uh,
there's another question here about an emissions measurement tool for farmers, basically, that I suppose it's a request, and there's probably is some projects in the line in terms of giving farmers tools that they can see if you were to deploy your system, how would it affect your emissions on the farm?
Yeah, absolutely. Look, as I say, there's levels of what can be done. Like anything is possible, really, but what can be done or what our offering is, and where that's a key consideration, or even down the line if carbon credits come along the line for us all. we can instrument it out with gas monitors to have continuous data to prove that the additive is working. Outside of that, more in a basic run, we can have a slurry based assessment. So slurry untreated gives you this amount of emissions. We treat it. Okay, that's the difference in it. You can clearly see what it's doing to the slurry.
All the slurries analysed then coming. Are you analysing slurry then coming out of tank before it goes to AD?
Yeah, absolutely. Yeah,
and then you get the analysis off the AD and then after, so you know exactly where you are.
Yeah. So we
that
have a very
analysis, I
robust.
think, is what a farmer will want to see. How much extra bang is in that cubic meter of slurry?
Yeah,
Yeah.
and that's really important because from the farmer's point of view, and for the Department of Agriculture, like if we're trying to reduce our nitrogen use and we're trying to achieve good fertility, if we don't know what's in the product, it's making it life hard for a farmer because if they're unsure, they'll just go to a bag and you couldn't blame it for them. So they need to have the information.
Yeah.
I'm going to ask you a really awkward question. I don't know, that the additive market is a busy market. What is your product doing differently than some of the other product sector?
Well, look, it's as simple as this, Carl. I'd say there's 15 years of research in it. We're not afraid to present our findings. The science is very robust. There's lots of peer-reviewed papers in it. So, a lot of additives will tell you one thing, but it's hard to find the evidence to back it up. Look, I think we're fairly confident to stand and say, look, this works and this is how it works.
And I think there's another couple of questions coming in there. It's an interesting one. Actually, I don't know if you can answer this or not, but do you think climate change can affect the slurry production?
Affects slurry production.
Yeah, the slurry coming into you. I suppose the question is based a bit around, are you forward planning on how our changing climates might affect what you're trying to do?
Well, I suppose we're trying to tackle that in the sense that we can, in the case of the cattle or dairy sector, by using our additive, you can really cut down on the emissions and maybe offset the notions of culls or anything like that. It's a readily available solution and it does work. So
I suppose for the cattle side of things, the effect of climate change might be different housing periods and length of time. And the other one is temperature is a key driver of emissions in storage. So winter storage at low temperatures versus if we're in warmer temperatures, there's going to be more emissions associated.
Fair enough. Yeah. So look, the additive will work at any temperatures. As I say, there's three factors that go into determining the duration of the effect and the amount of additive that's required, and that's primarily temperature and solids content. So if
I was going to ask,
increases,
as in summertime, if you were trying to say for supplying an AD plant to maintain the biomethane potential of the slurry there until July, it's going to take increasing amounts of additives as the temperatures start to increase compared to 10 degrees in wintertime.
Yeah, for sure. So you will need more additive now. It's not exponential amount of additive you'll need to add it to keep it going, but it may be more frequent. So if it's, for instance, every 2 weeks in winter, it might be every week in summer, kind of thing like that.
But you have a lovely automated system that we don't need to worry about it, is it?
Oh, for sure. Yeah. Look, we I say there's lots of research into what the temperature does to the effect and how long it needs. So that's all just titrated then back to frequency of dosing and volume of dosing.
It just reminds me of something you said a few minutes ago, Maurice, about slurry separation, and particularly in the dairy industry, we're seeing farmers looking towards different methods because rainwater and water get into tanks. I'm thinking in my mind that you're looking to put your product in slurry separation, but the slurry separation there's two ways of doing it. I suppose gravity fed, we're looking that way now where it's constantly happening. So and then versus maybe getting a contractor in to do a whole tank for you and separate it in kind of a December or January period. Can your system accommodate both those systems? Say if you have a gravity system where it's just separating all the time.
Yeah, I guess so. I mean, the best time to treat it is fresh. So look, you will obviously treat it at the top, and then the whole bulk of it is actually has received the treatment, and then as the gravity effect takes place, it's separating treated slurry.
And when you take out all that organic matter, then and you're left with a big liquid fraction, how will that work differently then with the product, or will it affect emissions maybe in some way?
Yeah, I guess effectively the solid portion then will obviously have more solids, so it may require a higher subsequent treatment if it's been stored for a long time, or if it's gone out straight away, it's fine. But if it needs additional dosing, it may need a higher treatment.
Yeah, so some farms they would separate from the tank, say with a screw press, and put the liquid portion back in that same tank. But effectively, they might need a slower dosing rate to keep the effect on the liquid portion that
Yeah,
went
for
back
sure.
into the same tank.
Yeah, there would be very little required for a liquid portion. There's not a whole lot happening in there really, so
Yeah.
it will be a small amount.
Just going back to the organic question, can you remind me what's in Gasabate again? What's in the additive?
So it's peroxide based, and so that's really the key to adjusting the ORP within the slurry. So you're essentially adding oxygen species, the reactive species in there that adjust the ORP.
Yeah. So when the peroxide is in, is that breaking down the organic matter? Is that kind of speeding up that process?
It's not speeding it up necessarily, but you're knocking out that one area that you don't want, which is the methanogenic activity. But your fermentation and other pathways will still continue unimpeded by the additive.
Yeah.
So if you were to turn off the system in February and leave the slurry there till July, you would get emissions again.
Yeah, absolutely. Yeah.
So so it's a constant drip thread, but that leads, I suppose, to an opportunity of being able to control emissions throughout the year, which is a nice idea as well. Where obviously we don't want to turn it on, but we want to keep them off. But it means you can leave them in tanks for long periods of time and just control the dosage to achieve that.
Exactly. Yeah. So look, we always talk about the closed period, but like that's not necessarily when all the slurry goes out. So say that maintenance dose approach gives the farmer flexibility on when he spreads.
Yeah, look, I suppose we have to remind everybody that we want slurry out in kind of that April to June, July period, and we don't want slurry out in the back end of the year at any time. It's not suitable for anything, in particular water quality. So I suppose best practice is always going to be the lead there. Look, our Dermot, I think that was a really good presentation, and it just shows the amount of questions that we got there. The engagement is excellent. And I think, unfortunately, we're out of time. And I had lots of more questions, and I think there's lots of stuff that's going to come across your plate that you're going to have to answer over time as well, with ever changing issues coming up. But I'd just like to thank everyone for submitting their questions. Really, really interesting, Dermot, and really like to thank you. Thanks a million for an excellent presentation and for sharing your knowledge with us this morning. Really enjoyed it. And Maurice, thanks a million for the questions. It's really, really good help this morning. And it's great that you have such a good knowledge on it, because you can really get the best out of the webinar. And just Yvonne Maher is across the way from here, and I'd just like to thank her. She's the driving force behind the show, and she's working away in the background, pulling the strings, keeping us all in the straight and narrow. So that's it. So until next week, we're going to be joined by Fiona Doolan next Friday morning at 9:30. And Fiona's going to be talking. She's an asset advisor and going to be talking about managing your farm during the winter period. So it's a very apt timing. We're coming into a difficult time of the year. The rain is starting to fall again. So she has some really good tricks and tips to help you keep you in the right way. So do tune in again next Friday at 9:30. But until then, I hope you have a great weekend. Slán go fóill.